code that you may not want to happen, so you have to catch them, right? You gotta catch the code error and you want to do something around it. Example, a calculator. Users are always going to do 0 divided by 0 and try and figure something out around you. Try to break the internet and the world and the universe and create a black hole. This was not what I did.
It's beer.
Well, so I went to the Commons to go get like, sparkling water. It's not. I was going to get sparkling water because it's like. But I like pushed the machine and it works. So I ended up getting like their lemonade, guava, something, whatever weird garbage. I was like, ugh, this sucks.
There's water. Just...
I think the sparkling water.
Oh.
Yeah. It's like a certain when you hit like a certain like. What was the guy who's on YouTube? He's like, once you hit a certain like income level, it's like water is not good for you anymore. So you have to have sparkling water.
What?
Yeah.
Sparkling water is good.
I can't afford it, so I go back and go to Commons. Kind of keep that lifestyle, you know.
Stay humble.
Water is not water. Do not tell me water is water.
I agree.
That is a false statement. Try Dasani and then try salt water and then try like
Maybe I'll-
Aquafina. Yeah,
Yeah,
water
like
is
Evian.
not water. Water is not water. Okay, so try accept. Try 0 divided by 0. Accept 0 division error. Please stop trying to break math. Right? So we get an actual error? No, we didn't get an error, right? Like above. My code broke. This would cause your code to crash. Right? This is a crash. Red is a crash. Red is bad. That is no good. Right? Down below, we said, hey, if this happens, there's my error, 0 division error right here. There's my error. There's my error, right? Which is this one up here, 0 division error. If I get this error, perform this action. Don't break the code, let it keep going, but do this instead, right? So, user wants to run into a wall, they try to go through the wall, the code doesn't break, right? It says you can't go through the wall and pushes you back over it. Right? Unless you're playing CSGO, your gun goes through the wall and you can shoot the enemy and yourself. You know, that's the way the real world works. Right? So Python looks for the accept block, whose error matches the one that was raised, and runs the code in that block. If the error is not found, it can't handle the accept. Right? The error is up here, it's not down here. If it's outside of the block, it will just error break. Right? That's why you see, if you're looking at some like older development code, the whole code is in a try block. Because if any error happens, it crashes gracefully. It's tries, it goes main, try, and then all the code. Right? Main, try, while, true, and then execute code. Right? So that things that when they break, things happen. Alright? Don't do that. So here's a try accept with a file. Right? So try with file name, as F, right? This will never happen, except 0 division error, ignore me, nothing's gonna happen, file not found, ignore me. Right? So which one is gonna execute? This one's real hard.
Wow, not found.
File not found. Just to show you. Right? So I'm going to open a file. I can't open the file. File's not found. Just ignore me. Right? This is a good way to, okay, input a file name. File name. That file's not found. Input another file name. Now they're in a loop. Right? Now they're in a loop. here we go, here's your divide function. Give me two numbers and I'll divide them, enter Q to quit. While true, first number, input first number. If Q break, send this out, completely breaks the true, or the while loop. If second number, input second number. If second number break, jump out. Answer first number divided by second number, print the answer. I'm a no good, lazy, bad person, and I'm gonna test your code. Oh no, I got a division by zero error. Whatever will I do? Right? So I can put it outside, I can put it inside, I can put it to the left, to the right, with green eggs and ham and all that kind of stuff. It'll catch it, and then it will execute whatever it says for me to do. Right? So whatever you need to do. You're a no good, lazy test engineer, and you find this, and then you need to write through your test script, and you say, okay, I'm just gonna do it this way, you move on with your life. Why would you do this? Because your senior engineer says, do not touch my divide code. Don't touch it. It works. Sure it does. You don't touch it. You just, there, I fixed it. Right? Found an error. You don't touch the divide code. You fix it outside. This is legacy code. This is your code. Right? Say maybe your partner is a divide code, right? Or their fight code. You run their fight code. It doesn't work the way you want it to. Something breaks. Something happens. You need to change it. You can't change their code. You can't change their code. You have to make their code work. Right? Yeah.
Define is just the function, right? Or
Divide.
Divide. Divide is the function.
Oh, so def is just calling, or just like
Diff divide. This is a
setting
new
it
one.
as a function.
This is a new one down here.
Alright, well, I know, but like that's what you use on the upper code,
Above.
right?
Yeah.
Okay.
It's, oh, that one's connected to the bottom of,
Yeah.
okay.
So that one's
Function.
connected to right here. Right there. Right there. Right. So I'm running the one above, now I wanna try accept.
So let's say we don't know the error. Let's say I'm trying to ask them to input a number from 1 to 5 and they give me 0. Like, could I use the try and accept for those type of things? So let's say I want a number between 1 and 5 and they input 0, and then could we do something with try accept to make them re-get their input?
You can create your own errors. But why? Is it gonna break your code in some way? It depends, right? Just write code around it. Unless it's like critical to break it, you can create your own. But I wouldn't do a try catch with something like, oh, you didn't input the number 4, right? That's just tell them to do it again, right? Tell them to do it again. So really what it's coming from and why you would use this is, right? Let's take the world outside of a user input, right? We're taking things outside of a user input. And you're rendering a screen size that you may not know on your phone, right? You're rendering a screen size. You know the iPhone 10, iPhone 11, iPhone 12, but iPhone 15 comes out, right? The screen size resolution is completely different than what you've been coding to, right? iPhone requests the website. It says, hey, I want resolution 1080 by 14 billion, right? And the website goes, I have no idea what you're talking about. I can't render at this size. Here's an error and the website crashes, right? Well, instead of crashing, just render it at this size, right? The item that you picked up off the ground is glitched, right, in a game, and it's got a negative value to it for some reason, and it passes it on to combat, and the combat engine says, I can't do a negative value, I'm just gonna crash, right? Well, instead, now just do 0 damage, right? Users just run around trying to do 0 damage on the wars, right? So it's a way to do this, like in that sense, right? let's try and, when we think about our code, think less of input a number, right? Because that's not the real world, right? That's not the real world, right? The real world is you're interacting with objects and items in the world that have their own code associated to it, right? Okay, so what's another way to do it? Well, here we can put everything in a try block inside the code. We put it inside the code. That's another way to do it. And then when stupid user decides to do it, 0, 0, it'll run different, right? Now I can do it again. We can run through this thing again. So we've caught it inside the function. If we look above, does it run again? No, it doesn't run again, right? Because the error happened in the function, and we caught it outside of the function, and then we did something outside. Okay? So the code will not continue to run in this sense, in this way. But we've caught it, and we've prevented, say, a crash or something else from happening. In the below code, we have the catch inside the try except inside of our function. When we catch it and it breaks it, we're still in our while loop. So all it's going to do is just say, hey, it's not working, and we're going to do it again. Right? Just start over again. You didn't push Q, we're still in the while loop. Does everybody see the difference between how these two codes are executing? Do I need to go up and show it again?
Oh, so you said
Yeah.
whenever the user presses Q, it's gonna run the try.
It'll quit, right? So above, that's our this is our def code, right? The def code, there is no try except in here. So when I run this code, when I run the divide code, remember this is the one without the try except. This is the one without the try except. So 0, 0. When we crash, we are crashing in the code. We crashed right here. Answer is this. This is where we crashed, right? Then the division error is passed up to divide, which is executed in the main, right? So there's nothing here to handle it in this function. It can't handle it. It doesn't know what to do with it. So it passes it up a level. Divide. We've called it in the main, right? Is there a way to handle it in the main? No. Crash. Code has crashed, right? So when I run it in this try except now, when I run it in this try except, let me zoom out just a little bit. Everybody still see that? Is that too small? Is it still okay?
Doable.
Better? Off of the bed? Okay.
Don't
I
matter.
know it's small. Okay. So just like before, enter first number, enter second number. Right? Enter first number, enter second number. It crashes. Where does it crash? It crashed in the code. It crashed in the function. Right? The function doesn't know how to handle it. The function doesn't know how to handle it, so it passes the zero division error up to the main function, the main call, which is divide. Divide will then say, hey, you have a zero division error. Here's your accept. Zero division error. And then it prints it out. Boom. Yes.
Why don't you put it in function?
That's what we do down below. Right? So in this one. Now we put it inside. Try accept. So now we can see that when we do the 0, 0, where does it put it first? First thing it sees is, okay, there's my catch. I'm catching it here. Right? Try catch, it's actually a step in Python. So I'm catching it here. There's my error. Have you ever taken math? But we're in the while loop still. So instead of executing this code, I say I just have an output. I just print it out. The while loop completes, and then we run back to the top again. And we run through it again.
So that try code is still being, is every time the loop runs, is running it, right? It's checking for it.
Yeah. So try, run this. Is there a zero division? No. Else print answer. Run code. Is there an error? Yes. Except print. Do I need else? No, because the except took over. While true, run the code again. It's going to keep going until you type in Q. This is gracefully handling the error. Above is not gracefully handling it, but it's two separate ways of handling errors, and understanding where you're going to put your error catches and things like that is important, right? It's important to understand how we can do this. Now, in the above, here, we do something like this, right? But does that really fix our problem? 0, 0. Runs it again. What happens when I do 0, 0? Oops.
It looks
Okay.
like it fixed.
Why is it running again? Zero, zero. Breaks. Okay, so we run this one. 0, 0. It runs it again. 0, 0. But it breaks. Why does it break? Because it's outside.
Yeah.
To catch. So I could encapsulate this with a while true and all that kind of stuff if I really wanted to, but you're just overcomplicating your code in that sense. Right. Yeah.
This could also be used to check to see if the user input is not an integer, right? If it does, what is the name of that error?
You can look them up, all the errors, I don't know what they mean. I don't know if it does. Right. And it all depends upon your code and what your code is doing, right? Because value error, right here, I'm converting in my string, I'm converting it to an int. So I can't convert a to base 10, but maybe I'm converting it some other way and the error does something different, right? So it may not be value error, it could be some other type of error, string conversion error or something else. So it all depends upon the error of the code and how it's being executed, right? So when we get into testing, right, when we get into the unit testing, we start throwing random garbage at our code to try and break it, you'll get these errors that you'll have to begin to do your exceptions and how to handle them in a correct manner so that when the code executes, it's giving you the output that you're expecting. Right? It's giving you the output that you're expecting. So file not found, basically same as above, right? No file found, easy. Try to open file name, this will never happen. Except file not found with open log text as this is wonderful. This is wonderful. I'm proud of this. This is beautiful. Right? As true programmers, hopefully one day, you should never, ever ever just output an error to the terminal? How many times do you sit there on your computer watching your terminal to make sure that the file is working right? That's what I meant. Put it into a log. You go look at that log somewhere, right? Windows breaks every 5 seconds. Do you see the errors? No, it's in the event viewer. It's a logging system. So where should your errors be? In a log file. The user should never see your error in any form or fashion. It should always be stored somewhere. Okay? It should always be stored somewhere. This is how you debug. This is how we solve problems. Right? On the previous program that I used to work on, you'd have your log open and you'd have your application open. And you would do something and you'd see it happen in the log. And the log would output literally everything from the back end. And you'd watch it. And you'd click here, click here, click here, and you'd watch your log. Click here, it broke. Error, 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 error. Copy, paste, send it off to the developer, move on with my life. Right? The developer will look at that log and the error output, and then they can go and solve what they need to do. A lot easier than saying file map. Right? I can put whatever I want into my log. I can plot all this information, date, time, information, system outputs, system times, user operating, what operating system I'm on. All of these things that might help the developer later on to figure out, okay, this crash only happens on Windows 11, but it doesn't happen on Windows 10. So there's something going on here, right? You can put all this information into the log file because you have all this space to do whatever you want to do, right? One of the biggest problems with try and accept, this is your question, I don't know anything bigger. This was your question. One of the biggest problems with accept errors is knowing which ones, right? You gotta know which one, what's breaking it, right? So, create a log file, where's the errors? Oh, so pretty. Create a log file, then you can then catch it later on and figure out what's going on with it. Especially if you want to be like a developer, the no good testers break something and you need to have a log to be able to find out what's going on with it. Right? Questions? None? Questions? Okay.
Oh, so going back to the 0 divided by 0,
Yeah.
is it frowned upon to have it just the try divide function and then accept instead of having the try and accept in the function? Because like why waste like process time like, in the while loop when you could just have it like outside of it and just
How do you want to write your code?
okay, so it's not really
This is better. Because if the accept never runs, the code won't run a cycle on it.
oh could you repeat that again?
If the error never happens, it will never run this, right? So you're not wasting cycles, right? You're not wasting any cycles on it. Right? I don't know the cycle count difference between it. I really don't. We could try and figure it out. I'll show you code down below that you can at home try and figure out how many cycle differences it is. I'll be 100% honest with you. If you're worried about cycle counts, don't use Python.
Sounds very ASM.
Python is amazing for prototyping. It is terrible for resource management. Right? You want to prove a concept, write it in Python. You want to actually write it, write it in C. Right? You send the code down to the junior engineer, here, write this in Python. It doesn't work, cool. Then the senior engineer writes it in C++, right? Or Hacktel or Fortran or whatever they want to use.
Fortran, wow.
Yeah, Fortran has it now. Right? So cycle counts are not ideal with Python. Python is a prototyping language. Really what it is. Right? You need to test something, you need to do it, you need to do it quick, you write it in Python, does it work? Fantastic. Do I need it to go faster? No, I don't care. Okay, perfect, it's done. Right. Python. Right. Okay. So now we're moving on. Okay, let me go back and re-emphasize. Log files are important. Log files are important. Log files are important. If you're accessing a file, you should always have a log somewhere. Okay? If you're accessing a file, always have a try catch with an error. If you would like, you can always, whenever you open a file, you open the file, you write to your log, opening this file. Accessing data from this file. Blah, blah, blah from this file. Right? You can generate all of these logs anytime you do anything. That way you can track when things get complicated. Most cases, you have as much memory as you want to work with. It doesn't matter. Right? You've got a 4 terabyte hard drive on that thing. You're not going to fill it up in a text file. Right? If you do, more power to you. Wow, I'm amazed. Yeah, for some reason, at my last job, they decided to put the logs in a 10 megabyte partition. And I was like, what is wrong with you people? Like, you've got a freaking RAID array with like 700 gigs in there. Like, why are you giving me 10 megabytes? They're like, because that's where we want it. I was like, you're dumb. Wow. And we'd always have these errors. Like in our application, we'd be like, can't write to log file because of file folder. And you're like, so I've got to like purge all of my documents. In a normal instance, it didn't matter, but when you were in testing, okay. So as I said before, in lab, we've completed everything with Python. Now we're going to start working on other things. And this is where Python begins to show its true colors. Right? This is where Python begins to show its true colors. So, did I already mess? No!